Hello everyone, I hope you guys are doing good and staying safe. Welcome to SimpliCode's YouTube channel, and in today's session, we'll be discussing about another important data structure, which is queue. Now, in a previous tutorial, we discussed about a data structure called stack, which works on the last in first out, or in short LIFO principle. And in this session, we will learn about another data structure, which is queue, and understand its functionalities and how to implement. So without any further ado, let's get started with today's topic. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest content, and hit that bell icon to never miss an update from us. So now, before we get into what queues are, so let's just understand what queues exactly are. So let us say many virtual messaging services like Instagram and WhatsApp nowadays are available today to fulfill the obligation of staying in touch with your friends and family. And while using them, you must have noticed that they preserve the order of your text messages hierarchy, whether the recipient is online or not. So this raises the question on how these messaging platforms preserve the sequence of text messages. Well, the answer, or the queue in data structures, contains the answer to this query. So every messaging application keeps a queue of messages waiting to be delivered to the user. So the queued messages are delivered when the user logged into the network. After that, the empty queue is removed. So as a result, whenever you text a friend, if they don't have access to the internet, the messages are queued up in, let's say, WhatsApp servers. So the messages are only deleted from the server once the queue recipient accepts them. So these messages are sent to the recipient or any retrieval by the recipient later. So the successful retrieval of any message is reported back to the WhatsApp server, where the recipient finally acknowledges that it has been received. And this is when you see the double tick mark next to your messages in WhatsApp. So this basically follows the principle of queues. So that is what brings us to what queues and data structures are. So queues is basically a linear data structure that represents a collection of elements in which an element is added at one end and removed from the other end. Well, if you talk about stacks, the operation is done only the one end, that is from the top of the stack. So the element that comes first will remove at the first place itself. But whereas queues operation can be done on the both sides, that is one at the end and at the front and the rear. So if you look at this diagram here, we are inserting three elements, let's say A, B, C. So the first one that goes into is A, followed by B, and followed by C. And similarly, the elements that goes first out of the this queue is also A and B, since they have entered first. So it basically follows the FIFO principle, which is first in and first out. Now there are a lot of real life examples as well. So let's take people standing in queue at a store is one of a simple example of how queue data structure works, or maybe people waiting in railway station for tickets, or maybe in hospital, and in like in petrol bunk, and many such examples are based on queue data structure only. Now, as discussed earlier, queue data structures follows the first in first out method, which is FIFO method. So in the concept of a queue, the first element to be inserted in the queue, that is at the front, will be the first element to be deleted or removed from the list. So the queue is said to follow the FIFO structure here. So let's now understand how a queue is represented. Now queue can be accessed from both of its sides, as we discussed earlier. So the insertion happens at the rear end of the queue, whereas deletion happens at the front end of the queue. So this is the rear end, this is the front end. So I'm just taking note here. The terms are similar to that, so you don't need to worry. So as what queue says is that insertion happens at the rear end, which is this. So it comes here. So let's say an element is inserting here, and next, whenever a next element is added to this queue, let's say I have inserted a value 1, and let's say another element 2 is added to this queue. So 1 will move ahead and the 2 will be added at the rear end of the node, and similarly it will move forward until the front node. So once the first element reaches the front node, the deletion will happen at the front of the queue, and the insertion will continue to happen at the rear end of the queue. So this is how basically a queue is represented, and I hope you understood this. So let us now move ahead and see how can we implement a queue. Now implementation of queue can be done by two ways. One is using a continuous memory by using arrays, and the next is using a non-contiguous memory data structure using linked list. Now there is also another way where you can use stacks as well, but it becomes a bit complicated. we will discuss about how to implement using arrays and linked lists in our execution part. So let us now move ahead and discuss some basic operations that are performed in queue. So firstly, we have the enqueue operation. So enqueue is basically used to insert a new element to the queue at the rear end. So we can insert elements in the queue till there is space in the queue for adding more and more elements. And inserting elements beyond the capacity of the queue will result in an exception which is known as overflow. So we generally say it as the enqueue overflow. Next, we have dequeue. Now dequeue is used to remove one element at a time from the front of the queue. So we can delete elements from a queue until it is empty. Trying to delete each and every element from the empty queue will result in exception known as underflow. Next, we have the peek. Now peek is used to view elements at the front of the queue without removing it from the queue. So we generally use a peek if you want to just remain it as it is, but without removing it from the queue. Next, we have the isFull. Now, isFull operation is used to check whether any more elements can be added to the queue or not in order to avoid overflow exceptions while performing enqueue operations. And finally, we have isEmpty or isNull operation. Now, it is used to check whether the queue has any element or not so as to avoid underflow exception while performing the queue operation. So, I hope you understood this basic operations in queue. Now, you'll get a more idea, you'll get more familiar on how to use this when we get into the execution part. So I think you have pretty much understood what queue is, how to represent it, and the basic operations. So that without any further delay, let us jump into execution part for queue operations. So as you can see, Visual Studio Code has started. So firstly, let us discuss an example to implement queue using an array. Now, using an array, it is one of the easiest method. By using a linear dimensional array, we can implement a queue. So let us understand this with an example here. So include the header files first, which is hast include iostream using namespace std. Next, we have to create an array, right? So I'm taking int max size of an array. I'm just giving it as 1000. You can give it as per your own choice. So for queue, we are giving a max size of 1000. So next, let us create a class queue, and inside that we will initialize all our member functions. So I am taking a private class here. So wherein I'm declaring an array variable int array of size, like we have declared max size, right? So initialize that only inside the int variable. So this is basically an array to store the elements of the queue. Now next, we have to introduce an front and rear elements of the queue. So for that, I'm taking another variable here, which is int front comma rear. All right. So next, let us take a public class, and in that I am going to give a constructor here, which is used to initialize the front and rear indexes of the queue. So the front will be set to -1 and the rear will also set to -1. So queue, I am creating a constructor here, which is queue. So set the values as front is equals to -1 and rear is also equals to -1. Now, why we are giving -1 here? So initially it will be -1. So whenever you keep an element, it will go to 0, 1, 2, 3, so on. So it will increment a value by 1. So let us now create a function to add an element to the queue. So let's just take a function void. Since we are inserting an element, it will become an enqueue. So I'm just taking a enqueue function as its name. So enqueue, and inside that I'm passing a parameter which is int element. All right. So this is basically a function to add an element to the queue. So, but before that, we are checking if the queue is empty or full. So for that, what I'm doing is open the brackets, and inside that, if Now the condition for the queue to be full is if rare equals to max size minus 1. So this is basically we are checking if the queue is full. So I want it to return cout queue is full. So I hope you understood this step. And end the line, or you can just return the value. Now similarly you have to give another condition where if front is equals to minus 1. So this is basically we are checking if the queue is empty. So we have to set it to front equals to 0. Alright. And then we will increment each value in the queue by 1. So we are doing the rare value. So whenever the element is adding at the rare end of the queue, we will basically add each an element and increment the value by 1. So I am doing rare plus plus here. Rare plus plus, and the element in the array will increment by 1. So the array element will be set to the element sorry, the value at the rare end will be added to the element value. So array of the rare will become the new element that will be added at the end of the queue here. So that is basically the point. Alright, so we have basically inserted a value by using a void function enqueue. We are passing an element as a parameter inside the function, and we are just checking if the queue is full or not by using these conditions over here. Alright, so let us now try to add a function to remove an element from the queue. So for that I'm making another function which is void dq. So we use dq in order to remove the element from the queue. So void dq is the function. So I've created a function which is void dq in order to remove an element. So inside the brackets. So we have to check whether if the queue is empty again or not. So if front equals to minus 1, then print cout queue is empty. Again, similar to what we have done for enqueue, it will be the same for this as well. So you're just checking whether the queue is empty or not. So end the line and return the value. Okay, now we are also checking if all the elements have been dequeued or not. So for that, once we have done with the part of checking whether queue is empty or not, I am incrementing the value at the front. So front plus plus, and if the front is greater than rare. So if the front value is greater than the rare value, that is basically you are seeing that if all the elements have been dequeued. So then the condition will be front is equals to rare minus rare is equals to 1. Alright. So this is a function for dequeue where we are trying to remove an element from the queue. Next, we have to write a function to get the front element of the queue, which is the first element that is present in the queue. So for that, I am taking another function, int, let's take get front. Let the function name be get front. And after that, we are passing again the if statement where if front minus is equals to minus 1. So if the queue is empty, which is basically we are checking cout is empty. Queue is empty. That's it, and return the value. Return minus 1. And the value will be returned at the return. And also you have to increment the value, right? So to store the value, you have to use return array at the front. Okay. Now we have to check, we need a function to check if the queue is empty or not. So I'm just taking another function which is of bool, it says which is true or false, which will take whether it is empty or not. Since is empty is one of the operations that we use to check if any values in the queue is empty. So return equals to -1. So we are done with all the functions where we are first inserted some values into the queue. We have removed some values from the queue, and we have checked the elements are there or not in our queue. So finally we are left with the main function where we have to pass the parameters and the values into our function. So I'm just creating a main function here, and inside that I am passing, I'm creating a variable q. So I'm passing all the values here. So q dot. So we have created a function nq, right? So nq, I am passing a value, let's say 10. Next, let us take another value, nq 20. So you can keep on adding values like this. The elements that you want to be present in your list, you can add values as per your choice. So q dot nq 30. So let's just take a final element 40 as well. So q dot nq 40. Alright, these are the 4 elements that will go into our queue. So see out. So we want to display the front element also, right? So for that I'm saying front element of the queue is, which is q dot, pass the parameter of the front element, which is get front is the function we have used. So get front in the value. All right. Next, let us try to dequeue some values also. So for that, q dot dequeue, we are specifying the function name here. So I am trying to dequeue the values 2 times. So q dot dequeue again. Now let us, after removing the element, let us understand what is the front element now. So see out, front element is, as the value, which is q dot get front is the function for that. So we have also inserted some elements, and then we have removed some elements, and we are checking simultaneously what is the front element after removing some element. So again, let us try to insert some values. So I'm taking again nq. So I'm just showing what are the various operations, guys, in a single program, instead of making it bulky and understanding it in different examples. I'm just adding them in a single example here. So I hope you've understood and you're on the same page with me. If you're having any doubts regarding the code, you can let us know in the comments. We'll try to clarify it as well for you. So now again, I'm adding an element which is 50. Now again, let's take another element which is 60, and the 2 elements I'm adding. Alright, so now let us try to print what will be the front element after adding these new elements. Front element is, so pass the function which is q dot get front. Alright, so I guess we're done with the code, guys. So let's just execute, and before we execute, let's just understand what we've done here. So in this program, basically we are defining a class q here that contains an array named ARR to store the elements of the queue. And we have 2 indices, which is front and rear, to keep the track of the front and rear elements of the queue. Now the enqueue function adds an element to the rear of the queue, whereas the dequeue function removes an element from the front of the queue. And we also passed a function which is getFront, where getFront function returns the front element of the queue. And also we have passed another isEmpty function, which will check if the queue is empty. And finally, in the main function, we are creating a queue with the name q, variable and performing some operations on it using the member functions of the queue class that we have created. So we have basically enqueued some elements like 10, 20, 30 and 40, and we are printing the friend element of the queue using the getFriend command here. So we are then dequeuing two elements, the first two elements, and again we are enqueuing two other elements, which is 50 and 60 into our queue, and print the friend element of the queue again. So again, after this, we can dequeue all the elements from the queue as well and print them also. That is up to your wish. So let's just execute this and see the output. So click on run and we will see the output. So as you can see, the output says 10 is enqueued into the queue, 20 is enqueued into the queue, 30 is also enqueued into the queue. So the elements that are present in our queue is 10, 20, 30. Next, we have performed dequeue two times, right? So 10 will be dequeued from the queue and 20 will be dequeued from the queue. Now the element that is left out will be only 30. Now after 30, we are trying to enqueue again two other elements, which is 40 and 50. So 40 is enqueued into the queue and 50 is also enqueued into the queue. So now the queue becomes 30, 40 and 50. So in this way, you can use queues using arrays. So I hope you understood this example. Now similarly, we can also implement queues using arrays. So let's just understand this. Now I'm just copy pasting the code that I have taken earlier in order to save time, and I'll be explaining what are the parameters or the factors that we have taken here. So as you can see, this is the program to implement queues using linked list here. So what are we doing here? So firstly, I have defined a structure for the linked list node where I've taken an int data and the node which will point to the next element. After that, we are defining a class for the queue where we are creating a pointer to the front of the queue and we are creating a pointer to the rear of the queue. And then I'm initializing this using a constructor for the both front and rear, and I'm setting them using a null pointer here. And also we are creating a function to check if the queue is empty or not. So if it is empty, we will return the front value, which is pointing to again null pointer here. Now we are creating a function void enqueue in order to add an item into the queue. So this is similar to that of what we did in array. Only the syntax changes here, where the node of the new node is pointing to the new node, and then the new node is pointing to the data and it will store the data. And then the new node is pointing to the next node, which is equals to the null pointer. So then we are passing the criteria here, where if the queue is empty, so the front and the rear will become the new node, else the rear will point to the next, which will become the new node. So and finally, we are enqueuing the data into the queue. So next, we have created another function to dequeue an item from the queue. For that, I'm using void dequeue as a function, and similarly we are checking if the queue is empty and we cannot dequeue, which is by passing the isEmpty parameter, which will check if the queue is empty or not. If it is not empty, we will pass the parameter accordingly, where we are setting the front to the next and we are displaying the values, that is the values are successfully dequeued from the queue. Next, we have the void display here. So we are creating a function to display the contents here. For that, I'm using the display. And finally, we have the main function where we are passing the parameters and adding values to our queue. So this program is using a linked list to implement a queue data structure. So the node struct defines a single node in the linked list, which contains an integer data and a pointer next to the next node in the list. The queue class here contains a pointer to the front and rear of the queue and provides functions to the enqueue, which is adding an item to the rear of the queue. And similarly, we have dequeue, which will remove an item from the front of the queue. And we are displaying the contents of the queue. And finally, the main function demonstrates how to use queue class to create a queue, enqueue, and how to dequeue items, and finally display the contents of the queue. So I hope you understood the code here. So let's just execute this and see the output. So as you can see, the output is 10 enqueued into the queue, 20 enqueued into the queue, 30 enqueued into the queue. So the elements will be 10, 20, 30 in that order. And next we are removing 10, 20 from the queue. So finally 30 will be the element again. Next we are enqueuing 40, 50 into the queue. So the elements will be 30, 40, 50. So in this way you can also implement queues using linked list as well, which are the both fundamental ways to implement queues. Now, the only advantage of using linked list over arrays is here that since linked list assigns memory at the time of creating, so the linked list can be increased as per the requirement, but whereas the arrays you have to specify a fixed size, which may not be suitable for some cases. So it is important that up to your requirement, what is your requirement, you have to use arrays or linked list to your best. So with that, we have come to the end of today's session, guys. I think we have covered pretty much about queues. I hope you understood also how to implement them using C++ language here with all these examples that we have discussed. Thank you for watching the video, guys. If you found this tutorial informative and helpful, give it a thumbs up and share it with your friends and colleagues. If you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. Stay tuned to the channel for more such amazing content. If you haven't checked out the previous tutorials on data structures where we have covered the introduction to data structures, different data structures like arrays, linked list, structures, stacks, make sure you check that out on our channel. We will leave the link in the description below. Until next time, thank you and keep coding.